Hi everyone, today we are going to talk about linear inequalities and we are going to use the inverse operation and we are going to use the distributive property to solve this exercise. I'm going to explain you these two exercises. I'm going to explain you how to represent with a graph notation and how to do it with a interval notation. Remember, inequalities is the opposite of equality, which is equations. We represent the inequality with a symbol less than, greater than, less than or equal to, or greater or equal to. And the equations will represent with the equal sign. There we have three examples of inequalities in real life. For example, we have the first one that we have that each class eliminate is $5. Or it's at least 5 is the less quantity that you have to pay for a glass. Now we have this one, we have a company A, and we have a cost, and the minimum cost is $10 in this case, $10 in this case. So these represent the minimum quantity, which is that you can represent with a less than. And then we have this graph will represent the coffee beans and the weight of 7 coffee beans. So we can find between these two quantities, or it's say between 0 and 1 and between 0 and 1.2, we have this specific value. Remember, inequality takes many values. It's not only one solution, we have many solutions. I have this example here. We have -2 open parenthesis y plus 5. So this one we can read like -2 multiplied by y plus 5 plus 3y less than or less than -12. Now we are going to use the distributive property to multiply -2 times y, which is -2y, -2 times 5, which is -10, plus 3y less than -12. Then we are going to arrange variables and constant, or it's a like terms. We have -2y plus 3y. Remember, we keep positive because we arrange or we put in the same position. We don't move the number to the other side using the inverse operation or using the transposition of term. So it's going to be -12 plus 10. Then we subtract -2 plus 3, which is y, or only one y, you can say, less than -2. Why -2? Because we have -12 plus 10, and remember different signs. We subtract 10 and copy the sign of the number with more absolute value, and in this case it's -12. Now here we have another, and this one we can represent in graph notation and interval notation. In graph notation means that we are going to take the number -2 and we are going to put open because we don't have the line down to the inequality, and we're gonna take values from the -infinite until -2, but don't include the number, the -2. So that means that you can take -1,000,000, -100, -50, -3, but not -2. And the interval notation, we put a infinite, comma, -2, and we put it open because we don't take that solution. Now in the second one we have -12 plus 3 multiplied by m minus 1 less than or equals to 2m plus 2. Then we have 3 plus m is going to be 3m, 3 times -1, -3 less than 2m plus 2. Then we need to arrange variables and constant, which is 3m, and this is positive 2m. We need to move as a -2m. Then 2, we copy this 2 positive because we don't use the transposition of term. Then this is positive 12 because using inverse operation we move as a positive. And then this is negative, we move as positive number. Then we have 2 plus 12 plus 13 plus 3, it's going to be 17. So m less than or equal to 17. The difference between this and this one is because we have the equal down. So we're gonna take values from 17, in this case I don't have it, but my index is from 17 until the negative infinite, or it's say from negative infinite until 17, and in this case we need to take 17. So in the interval notation we open bracket negative infinite, because remember these lines continue until the infinite, comma 17 close, because we take the solution, or because we have this line down. This is the explanation about how to solve inequalities using inverse operation, using distributive property, and 3 examples about inequalities in our daily life, the graph notation and the interval notation. I'm going to explain you an extra exercise. In this case we have the inequality between the elephant and the frogs. As you can see in this one we have an example, which is a station number 2, full capacity 30%. I'm going to represent this 3 exercise. We have 3 plus y greater than 4. So remember, variables with variable, constant with constants, or it's a literate. This is positive 3, we change as a negative 3. 4 minus 3, it's going to be 1. So y greater than or equals to 1. So it says that any value greater than 1 or equal to 1 we can take as solution. In this case we put 1, and then we can take 2, 3, 4, 5, 6, 7, 100, 1000, 3000, 30,000 and numbers until the positive infinite. So the interval notation would be close bracket 1, because we start with 1, comma positive infinite, open because we don't have or we continue taking and taking solutions. For example, if you put here 3 is greater than 1, yes. Now in this one we take the same idea and we have 2x minus 3 less than or equals to 1. This 3 is negative, we pass to positive, and we're going to have 1 plus 3 is equals to 4. Then we have 2x less than or equals to 4. Remember, applying, if we divide by one number in one side, we need to apply by the same number in the other side. So we divide by 2 both sides, and we're going to have 2 divided by 2 is equals to 1, and 4 divided by 2 is going to be 2. So now we're going to take values from 2, and it's going to be closer because we have the equal sign here, or the sign, the line, which is that you have to take the solution, and we're going to take values from negative infinite until positive 2. So we have negative infinite, comma, positive 2, close it. And these are some examples about inequalities, about how to solve inequalities with distributive property, with inverse operation, or with the transposition of term. And we have some applications of this topic in real